recording now. So welcome to our mini lecture. The only thing I wanted to remind folks about, and again, this isn't a formal lecture. All the formal lectures are on our YouTube playlist, and you can go through those. But this class is mostly about looking at graphs and identifying regions of the graphs and calculating the areas of basic geometric shapes. What sometimes confuses students, again, this is stuff you guys have been doing since you were in 8th grade, but maybe you haven't done it in a little while, so it may be a little bit more challenging to recognize that, yeah, okay, here's your basic triangle, and the formula for the area of a triangle, but maybe the triangle looks a little bit different, and you have to look at different parts of the triangle in order to figure out where the height is or where the base is, because the orientation is changed. So you might see that sort of thing. The other shapes that commonly come up, and so I'll draw a few more examples, is obviously, or maybe not obviously, but I think it's pretty obvious when you see it, is you're going to see also rectangles, and you'll have to calculate the area of a rectangle. So I'll draw a rectangle shape here, and so the area of a rectangle is equal to the length times the width of the rectangle, and so you might see that kind of shape. And then the other one that commonly you'll have to calculate is the area of a trapezoid. And this is another one that often confuses students. Again, because sometimes there's an orientation issue. So there's your basic trapezoid. So, and the area of a trapezoid is the average of the bases. So base 1 plus base 2 times 1/2 times the height of the trapezoid. Okay, so that's the formula. And I'll move it up a little bit to make some room. And so here is base 1, and base 2 is down here. Doesn't matter which one you call base 1, which one you call base 2. And the height of the trapezoid is the distance between the two bases. So it doesn't matter where you find the distance between the two bases, the height should be the same. If your trapezoid is drawn correctly, mine's maybe a little bit crooked, but it's just the distance between the two bases. But sometimes the trapezoid will be what they call a right trapezoid. And it looks like this. So you've got a right angle okay? And sometimes you'll have a trapezoid that is oriented differently. And these are like the common orientations. It's not going to have anything really, really crazy. You either have like a horizontal orientation or a vertical orientation, but sometimes again, that confuses students. So it's just things to look for. And then obviously there's your height. Okay. So I'll ask Matt, so is this all clear? Can you see what I'm talking about?
Pretty clear.
Okay. Now, this is kind of the, this is the point. So now I'm going to draw axes for a regular graph, and I'm going to draw what you're going to see a lot of on Ignithium in this class. You'll see a demand curve, and you'll see a supply curve. Okay. So then you can see, oh, wow, look, there's a big triangle there, right? See what I'm talking about, Matt?
Yeah, definitely.
Yeah, and we're interested in the area of this big triangle. The big triangle, and again, I don't have anything labeled here, but on the vertical axis, our units of measurement will be dollars, and on our horizontal axis, it'll be the quantity of some good that's being traded. So we calculate area here. You're doing units, kind of like you could think of like products sold, right? Number of products times the price of the product, right? And you're going to get an amount that somebody would spend, or the amount of money a company would be bringing in. That it's what we call revenue, right? So because of our units, all of these areas are going to be interpreted in terms of the amount of dollars, right? So that's, if I calculate this area, I'll get a number of dollars, like let's say $10,000 worth of economic benefit. And I'm talking generally here, we have specific labels for economic benefit. We call it total surplus. But when you read the Wall Street Journal or listen to some business stuff, you'll sometimes hear them say, "Oh, the market of used cars is worth, $10 billion," and you might scratch your head and be like, "Well, gosh, what do they mean? It's a $10 billion market?" Well, what they're really talking about, at least the journalists that are doing it the right way, is they're talking about the volume or the area here of this big triangle, and that's how they're, people on the back end that are helping them out, unless they're experts themselves, calculating when they say, oh, it's like a 10 billion market for steel or something like that. And then we're also interested in how you divide those benefits between buyers and sellers. So what we'll do is, and I'll park this over here, is we'll,
This is supply and demand, the lines.
yeah. The blue one is demand and the red one is supply.
And then Q is quantity.
Yeah.
Okay, cool.
And then we'll identify an equilibrium price here, right? And I'm just talking stuff in really high level. This is just to kind of, help you out as you go through the material, like, oh, okay, what am I supposed to be looking at? Because you're going to hear all of this language and all of these terms. But at the end of the day, all it boils down to is there's another triangle, right? Now I've divided the big triangle into two littler triangles. right?
Yeah.
And so each of these littler triangles that are divide the big triangle, right? Based, and here's where we'd have the equilibrium price. So the equilibrium price is dividing that big triangle into these two little triangles. Each of these have a different interpretation. The bottom one is what we call producer surplus. It's the share of the economic benefits that go to sellers. And the upper triangle is consumer surplus. But it gets even better than that. So I'll, and again, this is a very high level kind of commentary. So um, it's just big picture stuff. But a lot of times we'll say something happened, um, and usually it has something to do with the government, right? Doing something. And now we're going to talk about a different price level, and we'll add a specific line here, right? And this is one of the first topics you come across is the government price restriction. Um, this one's called a price floor. But now, if you look, you go, oh, okay, the government's restricting the price. And because of that restriction, people don't want to buy as much as they did before. And so now we'll say, okay, that government price ceiling or price floor in this case um, is affecting the quantity. Normally, people would want to buy this quantity, but they don't because the price is too high. And now look at all of the interesting areas you have. You got a little triangle up here. Uh, so you got that little triangle, right? You got another triangle here, right? And now you have this right trapezoid here, right? Do you see what I mean, Matt?
Yeah. Yeah.
And again, each one of those has a different interpretation. So there's consumer surplus, there's producer surplus, and then this is lost potential economic benefit that we call deadweight loss, because it's benefits that would have happened but are no longer happening because of the government price restriction. Okay, and so that's just an example of how you can end up getting trapezoids. And I'll give you just one other quick example. Um, so the one other quick example is, now suppose that instead of imposing a price restriction, the government just says, oh, okay, people cannot produce. And again, you might think this is kind of crazy, but it's a fact that the government has done this. People cannot produce any more than a certain quantity of a particular good. So instead of having that price ceiling in place, the government just nails the quantity down and says, listen, you can't produce any more than this Q with exclamation point. So now hopefully you can see, and I'm not saying no price is going to emerge, because again, I'm just trying to identify shapes that you all are going to be calculating and interpreting. But now you can see we have another trapezoid, right? But it's not a right trapezoid. It's a regular trapezoid, and you've got a triangle that's splitting that area. So that's what you're going to be doing this whole class. You're going to be figuring out how these different economic policies end up dividing potential economic benefits and how they're measured graphically. And that's really the substance of the math in the course. And oh, one other thing, because I didn't show you all a rectangle yet. So another example of this is, so let me do this. Is that notice that from that trapezoid, I can isolate a rectangle too. And it turns out in certain contexts, you'll have to do that because there are other government policies, and the one in particular you guys are going to be learning about pretty quickly is a tax. A tax does this, where it creates an area here that corresponds to tax revenue, which is a rectangle. And then again, you have your deadweight loss area and your consumer surplus area and your producer surplus area. And yeah, that's what you do in this class. Okay. So do you guys have any quick questions for me? No questions? Okay.
So when you're taking the area of one of these sections, you
Mhm.
have the units are dollars in quantity, right?
Right.
So when you multiply them, wouldn't the units be dollars times whatever object you're selling? Or?
Well, yeah, okay, but okay, let me do a little example for you, because this is a good question, right?
Mm-hmm.
What's something you buy a lot of?
Let's say toast.
You buy toast. Or how about gallons of gas you drive?
Yeah.
Yeah. So you go to the gas station, right? And you buy quantity of gallons, right? Times the price per gallon, and that gives you the total amount of money that you've spent. You
Oh,
see what I mean?
sure. Yeah. I see.
Right? So
Yeah.
quantities times dollars is dollars.
Mm-hmm. I see now.
Yeah. Good question. Okay. Any other quick questions? No? All right. I'm going to stop recording.